Hello, good evening, everybody. I'm Muniz Zahir. Last time we discussed about the plastic analysis and design of beams. So in today's lecture, we will discuss about the plastic analysis of frames. We will solve some problems. So let us take first problem here. The statement of the problem is find the collapse load for the portal frame as shown in the figure. The beams and columns are of the same cross section. So this is our portal frame. Okay, we have the last moment capacity of the beam as well as the columns, both are same, MP here and MP here. Okay, so we have to find out what will the collapse load for this portal frame. So you know that the plastic hinges are formed at the fixed supports here, okay, at the joints and under the load. So these are the possible locations of the plastic hinges. So these possible locations of plastic hinges are at A, here, that is fixed support, B, that is at the joint here, C under the load, and D again at the joint. So therefore, number of possible plastic hinges, capital N, is equal to 4. 1, 2, 3, 4. Okay. Then what is the degree of redundancy of this frame? So we have, this is our fixed supports. We have 3 reactions here and we have 2 reactions here. So 3 plus 2 is your 5. And number of equations available to us is 3. So 5 minus 3 is equal to 2. So degree of redundancy of this frame is 2. Now generally there are n minus n independent equilibrium equations. So therefore number of possible independent mechanisms are capital N minus small n, that is 4 minus 2, that is equal to 2. So these are the number of possible independent mechanisms. So these two independent mechanisms include, number one is your beam mechanism, that is this is our beam mechanism here, okay. Then second is a sway mechanism. This frame under this horizontal load will sway to the right side. Now these two independent mechanisms can be combined to form a combined mechanisms. We can combine these two mechanisms, that is the beam mechanism and the sway mechanism, to obtain a combined mechanism. So let us calculate the collapse load for each one of them. That is, first we calculate for the beam mechanism, then sway mechanism, and finally we calculate for the combined mechanism. So let us take the example of beam mechanism here. So this is my beam here, BD, subjected to a central point load, that is WU. Okay. So this is my joint here. Beam column is here, beam is here. So this is my joint. Again, this is my joint. So one plastic is formed here, one formed here, and one directly under the load. So suppose that this beam is rotated by this angle theta here. So this is theta here, this is theta here. Okay. So at the center of this beam, this is nothing but your theta plus theta. Okay. So this exterior angle, you can see this triangle, this exterior angle equal to this sum of the interior opposite angle, that is theta plus theta. So here, how to calculate the collapse load? We have to equate the external work done is equal to internal work done. Now this external work done is equal to how much? Load into deflection. This is load and this is my deflection, delta here. Okay. So if we multiply this by this, so we get the external virtual work. So this is equal to, load is WC and deflection at the center is this distance from here to here is your L by 2. This is again your L by 2 here. Okay. So this deflection at the center delta is equal to L by 2 times of this theta. So this is my deflection here. Okay. Now internal virtual work or internal work done is equal to, this is how much is equal to, now this is your plastic moment MP here. So MP multiplied by theta. Here it is MP multiplied by theta plus theta. This is 2 theta. And this is MP times theta here. So total is your 4 MP theta. So we have to equate by the principle of virtual work. We have to equate the external virtual work is equal to internal work done that is equal to WC L by 2 theta is equal to 4 MP theta. So we get WC is equal to 8 MP by L. So the beam mechanism, if you consider the beam mechanism, the collapse load comes out to be 8 MP by L. Now come to the sway mechanism. Now under the action of this horizontal load, the frame will deflect to the right side. So this is my deflection delta here and delta here. Okay. Now where are the possible location of plastic hinges? Because this is your fixed support in the frame. So one plastic hinge is formed here, another is formed is here, third one is here, because this is your joint, this is your joint. Now here this is your hinge support. So no plastic hinge will form at this location. So we have only 3 plastic hinges, 1, 2 and 3. So the columns AB and AED are of the same length. So this column is equal to this column, height is same. So this means that these deflect by the same amount delta here. So the rotations at the ends are also same. This is theta, so this is also theta. So these are the possible locations of the hinges. Now external work done is equal to how much? WC into this distance. Now this distance is again given in the problem is L by 2. So this is deflection, this delta is equal to L by 2 times of this theta. Okay. Now internal work is equal to how much? MP times theta here plus MP times theta here plus MP times theta here. So this is 3 MP. So by the principle of virtual work, equate this one to this value. Okay. So this is equal to WC L by 2 theta is equal to 3 MP theta. So we get WC as 6 MP by. In the beam mechanism, we got the WC as 8 MP by L. Here it is 6 MP by L. Okay. Next, we have to consider the combined mechanism. Now, this beam will deflect this way, okay, under the action of this load which is coming on the beam. And this frame will sway to the right under the action of this horizontal load. Okay. Now we have to see where are the possible locations, where are the locations of the plastic hinges. So we'll see here, the possible locations of plastic hinges are A, C and D. Here A, C and D. Okay. A plastic hinge does not develop at B. This plastic hinge is not developed here. Why? Because as the length BC of the beam, this length of the BC of the beam is deflect in the clockwise direction under this load. Okay. Similarly, this column, that is BA, under this horizontal load again deflect in the clockwise direction. So the net angle between this beam and this column remains 90 degrees. There is no change of angle here. In the initial condition, the column and the beam are straight. So angle between the two is 90 degrees. Now in the deflected portion again, because this is rotated clockwise, this is also rotated clockwise. So angle between the beam and the column did not change. It remains as 90 degrees. When the angle remains 90 degrees, no plastic hinge will form here. For plastic hinge to develop, the angle should change from 90 degrees. Okay. As in the case here, so you'll see that this beam DC portion deflect in the anti-clockwise direction. So there is an angle theta here, anti-clockwise. And this column, because of this horizontal load, deflect to the right. So this is your clockwise rotation. Okay. So this is theta here and this is theta here. So there is a net change in the angle. How much it is? Theta plus theta. Now these two links is not making angle of 90 degrees as in the case here. So this means that the plastic hinge is formed here, not here. Okay. The explanation is given here. Okay. This is your explanation. Now let us calculate the external work done is equal to how much. So external work done will comprise of two loads, one for this one and one for this one. So this is one WC into L by 2 times of theta, okay, plus WC into L by 2 times of, this is L by 2 and this is your theta. So this is external virtual. So this is equal to WC L theta. Now what is internal? Here it is MP times theta, this one. Okay. Now here is no hinge here, but the hinge is here. So MP times theta plus theta, MP times theta plus theta, plus again mp times theta plus theta, mp times theta plus theta. So this is all is equal to 5 mp theta. So by the principle of virtual work, equate the two. So we'll get the WC as 5 mp by L. So we have three collapse load. One under the beam mechanism is 8 mp by L. Okay. Then in the sway mechanism we have 6 mp by L, and in the combined mechanism we have the 5 mp L. So what is the least one? Least one is 5 mp by L. So the collapse load is that load which is the least one. So the collapse load will be equal to 5 mp by L. So this frame will fail in the combined mechanism because the collapse load comes out to be minimum in case of combined. So this is your first problem. So let us see another problem here. Find the collapse load for the frame of uniform cross section under the upright loads. Now here you will see that this is your hinge joint A. Hinge is here also, okay, and we have a horizontal load not acting at this joint. It is acting in between the. This is acting at a 3 meter from the top. So you have to find out what is the value of the collapse load. So possible location of plastic hinges are, because this is your hinge joint, so no hinge here. The first hinges will be here, B, then at C, then at D, then at E. No hinge again formed here because it is a hinge joint already. Okay, so we have 4 location of the plastic and equal to 4. Then degree of redundancy is how much? This is hinge support. So 2 reactions are there. 2 reactions are there. 2 plus 2, that is your 4. Okay, and we have number of possible equations are 3. So 4 minus 3 is equal to 1. Okay, so generally there are capital N minus small n independent equilibrium equations. So number of possible independent mechanisms how much is equal to 4 minus 1, that is equal to 3. So 3 mechanisms are, number 1, beam mechanism in span C. So this span is your C, so we have a beam mechanism here. Then beam mechanism in span AC. So because this load is acting at this height 3 meter from the top, so again this is your beam mechanism for this column. Okay, then we have the sway mechanism under this horizontal load. Okay, now these sway mechanisms can be combined with each of the beam mechanism to form a combined. Now here this mechanism is first combined with this beam mechanism, and then next time it is combined with this beam mechanism to form a combined mechanism. So let us consider first the beam mechanism, that is span C. So we have, this is my diagram here. Okay, now external virtual work will be how much? External work is equal to internal work done. Okay, so what is this? 80 multiplied by this distance. Okay, so this is nothing but your 3 meter here. This is given in the problem. So this is 3 times theta. This is external work done is equal to how much is the internal? MP times theta here plus MP times theta plus theta here plus MP times theta here. Okay, so we have 24 theta, 240 theta is equal to 4 MP. The MP is equal to 60 kilonewton. Okay, very simple. So beam mechanism, the plastic moment for this case is your 60 kilonewton meter. Then consider beam mechanism span AC, that is your column here. This is my column, and the load is acting at 20 kilonewton at a distance of 3 meter from the top. So this is 3 and this is your 6 meter. Okay, now because the load is eccentric here, so these two angles are not same. Suppose that this is my theta, so this is your theta 1. Okay, and exterior angle is equal to theta 1 plus theta. So let delta is equal to how much it is equal to? This is my 3. 3 times of theta 1 is equal to 6 times of this theta. Okay, so from that theta 1 is equal to 2 theta. Okay, now the principle of virtual work we have to apply. 20 into 6 theta. This is 20 multiply, this is my 6 meter. 20 into 6 theta is your external work done. And what is internal? How much it is? There is no hinge here because it is already hinge joint. So we have first hinge is here, MP times theta 1 plus MP times theta 1 plus theta. Okay, so this is 120 theta is equal to MP times, now in place of theta 1 I write 2 theta here plus MP times, this is theta, in place of theta 1 I write 2 theta. So solve the two, we get the 120 theta is equal to 5 MP theta. So MP is equal to 24 kilonewton meter. So this is the plastic movement capacity for the span AC. Next, we have to consider the sway mechanism. Now, under this horizontal load, the frame is swayed to the right side. Okay. Now here, because this length of the column is different than this length, so the angle here and here are different. So here, if I assume here is theta, so this is one is your now theta 2. Okay. Now 9 delta, this is 3 meter here and 6 meter here. So total is your 9 meter. So 9 times of theta is equal to, this is my 6 meter, 6 times of theta. So theta 2 is equal to 1.25 times of theta. Okay. Now apply the principle of virtual work. So what is this? 20 into this is my 6 meter. 6 theta is equal to, now here internal work will be how much? At this in MP times of theta plus MP times of theta 2 here. Okay. So this is 120 theta is equal to MP theta. In place of theta 2, I write 1.5 theta here. Okay. So this is 1.5 theta. So solve the 2, you will get this value. And finally, MP comes out to 48. Okay. Next, we consider the combined mechanism. So first we combined with the sway and the span CE. First, I combined sway mechanism with the span CE, this one. Okay. Now, plastic hinge will form at this location and this location. At this location, there is no plastic hinge. Why? Because this is rotated clockwise. This column is also rotated clockwise. So there is no change in the angle here. This remains 90 degrees. So as I explained you in the previous problem, when the angle between the members remains 90 degrees, the hinge will not form. Okay. So by the principle of virtual work, 80 into this is my 3 theta. Okay, 80 into 3 theta plus 20 times this is my 6 meters. 20 times 6 theta is equal to MP times theta plus theta here plus MP times theta plus theta 2. Theta plus theta 2. Now in place of theta 2, I write 1.5 theta here directly. Okay, so just solve that equation. So we have 360 theta is equal to 4.5 MP theta. So this comes out to be MP is equal to 80 kilonewton. Next, we have to consider the combined mechanism, that is sway and span AC. This is sway here and span AC also. Okay. So this is my span AC for the beam mechanism. So by the principle of virtual work, external is equal to internal work done. So this is how much. Now, first we consider, suppose that beam mechanism here. So 20 multiplied by this is your 6 theta. 20 into 6 theta. Plus again. Now consider this load for sway mechanism. So 20 multiplied by again 6 theta. So 20 multiplied by 6 theta is equal to, now hinge will be here as well as here as well as here. Okay. So this is your MP times theta plus theta 1 plus MP times here theta 1 plus MP times of theta 2 here. Okay. So just put the value. This one is your 240 theta equal to MP times theta. In place of theta 1, I write 2 theta. In place of theta 1 again 2 theta. Theta 2 as 1.5 theta. Okay. So just solve it. So we get this value. Okay. And finally we get MP is equal to 36.9 kilonewton meter. Okay. Now we have 5 values here for MPs. One for this beam mechanism, one for this beam mechanism, one for sway mechanism, and 2 for combined mechanism. So we'll see what will be the maximum value for this plastic moments among the 5 values. So the maximum value comes out to be for this frame is 80 kilonewton meter, which is nothing but in the previous case, that is combined mechanism, sway mechanism with this beam mechanism. So plastic movement of the frame is comes out to be maximum value, that is your 80 kilonewton meter. Now we'll take one more example here. Determine the value of plastic moment for the frame as shown. The plastic moment is uniform throughout. Now in this case, we have a UDL on the top here of 20 kilonewton. Now this is your hinge joint. This is your hinge joint. So no hinge will form here. Okay. Although dots are showing here, but the hinge will not, plastic will not form at these 2 points. Okay, so we'll have to calculate the value of plastic moment. What are the possible locations? First location at this joint, second at this joint, and once at point E, somewhere in between B and C. So we have B, C, and E. So total possible locations are 3. Degree of redundancy how much? We have 2 reactions here and 2 reactions here. So 2 plus 2 is 4. Minus of 3 equations are available. So this is your 1. So number of independent mechanisms how much is 3 minus 1, that is your 2. So 2 mechanisms are, one is your beam mechanism. This is your beam mechanism for this one BC. Then we have sway mechanism under this horizontal load. And these 2 independent mechanisms can be combined to form a combined mechanism. So first calculate the beam mechanism here. So by the principle of virtual work is equal to external work done will be how much is equal to, for UDL it is nothing but intensity of the load into area of the mechanism diagram under the load. So whatever the intensity, that is UDL, multiplied by this whole area of the triangle. So that is nothing but your external work. So this is equal to how much? Intensity is 20 and area is half. Base is 5 plus 5 is 10 meter into height. This height is your, this is your 5 times of theta. Okay, 5 times of theta. So this comes out to be 500 theta. Now internal work is equal to work absorbed by the hinges. How much it is? Now here this is one hinge here, MP times of theta plus MP times of theta plus theta here, second one, plus MP times theta here. So 4 MP. So equate the two, we get 500 is equal to 4 MP theta. So MP comes out to be 125 km. Okay. Then consider the sway mechanism. So under this horizontal load, the beam sway to the right side. Okay. So equate the two. External work will be how much? 100 into this distance. So this is your 3 meter. 100 into 3 theta. External work done is equal to internal will be how much? Plastic hinge here and here only. No hinge here and here because it is your structural hinge. Okay. So this is your MP theta here and MP theta here. So we have 2 MP theta. So it is 150 MP. Next, consider the combined mechanism. Now this is my combined mechanism. Now under this horizontal load, okay, this is your sway, and under this load, this is your beam mechanism. Now under this condition also, the beam deflects to the clockwise. Under this horizontal load, the column deflects again in the clockwise direction. So the angle remains 90 degree here. So no plastic hinge will form at this point here. Okay, the plastic hinge will form somewhere in between B and C at point E, which is at a distance of x from B. So we have to calculate what is the value of x here. Okay. Now, and another hinge is formed at this point. So plastic hinges between B and C is formed at a distance x from B and not at the center. Why not at the center? Suppose that if this horizontal load is not acting, then in that case it is acting at the center. But because this load is acting, so we do not know where is the maximum bending moment here in this beam. So we have to calculate what will be. We have to first write the equation for bending moment in this portion. Okay. And then equate this bending moment dm by dx is equal to 0 to find out what will be the value of x, and then finally we have to calculate what is the value of the moment here. Okay, let the vertical deflection at E be delta. Suppose that we have deflection here is delta. Now equate the two. This delta is equal to how much it is? X times of theta. X times theta times x is equal to, now here it is theta, here it is theta 1, because I don't know whether this x is equal to this x. So that's why I consider this as a theta and this is a theta 1. So theta 1 times 10 minus of x. So we have to calculate theta 1 from this expression. So this is my theta 1 in terms of theta. Okay. Now external virtual work will be how much? 100 times, this is my 3 meter, 100 times 3 theta. Plus this is my 20 into area of the triangle, half, base is 10 meter, from here to here it is 10 into this height. So this height is nothing but your theta times x. Okay. Now solve it. So this comes out to be 300 theta plus when you solve it, it comes out to be 100 into theta x. Now internal virtual work will be how much? So no hinge is here, only hinge here and here. So this is MP times theta plus theta 1. MP times theta plus theta 1. Again here, MP times theta plus theta 1. Okay. So MP times, in place of theta 1, I write this expression. This one. Okay. Here theta 1, I write this one. Okay. So just solve it. So we have this value and this value both are same. So this is twice of MP theta plus theta x divided by 10 minus of x. So this is my internal virtual work. Now we have to equate the two. External is equal to internal. Okay. So this is equal to 300 theta plus 100 of theta x is equal to twice MP. Take the LCM of this one. So 10 minus x. So this is 10 minus x times of theta plus theta into x. Okay. In the next step, I took 2 to the denominator here under this one is equal to MP times. Now open it. This one. So 10 minus x. This is plus x. Take theta outside. Divide by 10 minus x. Simple step. The next is what I will do here. I took 100 theta outside as common. So this is 3 here plus x here divided by 2 is equal to MP times. This x cancels out. So this remains 10 times theta divided by 10 minus of x. Okay. Now this theta and this theta cancels out. So what it remains here? MP is equal to how much? 100 here. 3 plus x multiplied by this value 10 minus x divided by 10 here and 2 from here. Okay. So this just further solve it. So this is equal to how much? Now this from this 10, I just cut 1 0 here and this remaining 10 I took outside here. So this is equal to 3 plus x 10 minus x divided by only 2 remains here and this 10 comes outside. This is kilonewton meter. Now in this expression I have to find out what is the value of x, that is at what location the hinge will form from the joint. So what I will do, for MP to be maximum I have to differentiate dMP by dx equal to 0. Okay. So this is how much? This is 10 by 2 here. 10 is this one, 10 by 2 here. Now differentiated by parts. So this is 3 plus x as it is. When you differentiate this one, this becomes minus 1 here. Plus again, when you next time you have to take this one inside and you have to differentiate it with respect to x. So this is only plus 1 equal to 0. Now this is 10 by 2 here. Just open it. Minus 3 minus x plus 10 minus x equal to 0. So this is 10 minus 3 it is 7 minus of 2x equal to 0. Okay. So this comes out to be x is equal to 7 by 2, that is 3.5. So hinge will form at a distance of 3.5 meter from the left joint. So what is MP here? Just put this value of x here in this value here, MP. So this is 3 plus x is 3.5. 10 minus 3.5 divided by 2 into 10. So this comes out to be MP equal to 211.2. Now this is 211. So what is the maximum value here? So this is comes out with the maximum value among the various beam mechanisms, sway mechanism in the combined method. So this is the plastic movement capacity of the frame. Now next time I will now here I will take two wave portal frame here and the loads are 40 kilonewton here and 60 kilonewton here, 3 meter here, 3 meter here, and all the columns are of MP, plastic movement capacity is MP, all the beams are twice of MP. Okay, this is column height is 6 meters. So we have to find out the value of MP so that the frame would just collapse under the given loads. So there are two beams. This is one beam here, PF and FH. So first of all, my target is I have to calculate the degree of redundancy of this frame. So for calculating the degree of redundancy of the frame, one method is you have to make it a cut here in the beam here. One cut here and one cut here. So when you have to make two cuts here, so degree of redundancy of this frame will be how much is equal to two of the cuts, and by cutting there are three forces, okay, which are released. So 3 into 2, that is equal to 6. So this is the degree of redundancy of this frame. Very simple. So number of plastic hinges are how much? Because these are fixed, okay. So one at each support at A, B, and C. A, B, and C. One at top of two columns. This column and this column. I will not consider now this as a column. I will tell you later on. So this is at one column AD and the another column is CH. So there are two columns, that is 2. Okay. Then one under each point load. So this is my point load, this is my point load, E and G. Okay. Then there are three members meeting at joint F. Now this is your joint F here. Now we have a joint mechanism also. We have beam mechanism, we have the sway mechanism. Similarly, we have the joint mechanism. Now joint mechanisms are established when there are more than two members. So here there are three members. One is this beam, and this column. Okay. So there are three members at the joint F. So in case of joint mechanism, one hinge is formed in each member of the joint. So we have one hinge formed here, another is here, and third one is here. Okay. So basically at this joint we have three hinges formed in each member. So F is equal to 3. That is at joint F we have 3 plastic hinges, one in each member of the joint. So total number of plastic hinges how much? Add all these things. Also this is consumed with 10. Okay. So number of possible independent mechanism will be how much? We have the hinges 10, and this is my degree of redundancy 6. So this minus that is your 4. So it consists of how much? Two beam mechanism. One is this one and another is this. Okay. One sway mechanism. Under this load, the sway deflect to the right side. Okay. So we have only one sway because as the frame is single stage. Then we have the joint mechanism also. Because of this member meeting three members here, so we have the joint mechanism, that is one. So we have two beam mechanism, one sway mechanism, and one is your joint mechanism. Now, the important point is that it is worthwhile to mention that joint mechanism itself is not formed. That is, it does not form as independent mechanism. It is somewhat like the combined mechanism, as we have already calculated from in the previous product. So we have the joint mechanism here. Now let us consider the beam mechanism. So we have here, now please mention this one, the column plastic moment capacity is MP and the beam all are 2 MP. So this is beam is your 2 MP, okay, 2 MP, and column is your MP. So you know that when the beam and column are meeting, the hinge will form in the weaker section. So this is MP, this is weaker. So hinge is formed in the column in this beam mechanism. Okay. Similarly, in this beam mechanism, hinge will form not here in the beam, but in the column here, because the velocity moment capacity is only MP. Okay. So we have two beams. Let us first calculate for beam DEF. This is my DEF. Okay. So this is 40 into 3 theta external work is equal to how much? MP times theta. This is MP times theta. Okay. Plus twice MP times, because the plastic moment capacity of beam is twice MP, multiplied by theta plus theta is 2 theta. So 2 theta. Plus this is formed in the beam. So this is your 2 MP times and this is your theta. So just add the 3, we get 7 MP theta. So this comes out to be 120 equal to 7 MP theta. Here MP is equal to 17.1. Similarly for beam FGH. So this is equal to 60 into 3 theta external work is equal to, now twice MP into theta, this one, plus twice MP into 2 theta, this one, plus MP times, this is because this plastic moment capacity of this beam is 2 theta, sorry, 2 MP, and this is your MP. So it forms in the weaker section here. So this is multiplied by MP multiplied by theta. So again it comes out to be 7. So this finally comes out to be 25.7 kilonewton. So we'll see that in these two beams, the plastic movement capacity of the right beam will be higher, that is 25.71. we will use this higher plastic moment capacity among the two beams in the later stages. So next is your sway mechanism. So under the action of this load, the beam sway to the right, deflect to the right. So we have plastic hinges formed. All hinges are formed in the column. Why? Because the moment capacity of the columns is all are empty and beams are 2 empty. So it forms in the weaker section. So one is formed here, another is here in the column itself. Here, 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 here. So we have 20 into 6 theta is equal to how much? 1, 2, 3, 4, 5, 6 hinges. So this is MP theta, MP theta. So these are 6 MP theta. Okay. So solve this, we get the 20 kilonewton meter. Okay. Next is the combined mechanism. So this is your combined mechanism. So I will combine here with the right beam mechanism here, not with the left. Why? Because combined mechanism can be formed with left hand beam mechanism with sway mechanism or right hand beam mechanism with the sway. Now as MP for the right hand beam is higher, as I told you in the previous slide, 25.71, we adopt right hand beam mechanism with the sway. So we have to combine the sway mechanism with the highest plastic movement capacity of the two beam mechanism. So highest one is your right one. Okay. So this is equal to how much it is. This one is your suppose 20 into 6 theta. Okay. Right beam mechanism here it is again 60 theta, 60 into 3 theta, 60 into 3 theta. This is equal to 1, 2 MP theta here. So MP theta, let us start from here. First one here. Now I will consider these three hinges in the last. So first one here, this is your MP theta. Okay. Then come here. Now here you will see that we have a joint here, joint mechanism. So this means that the hinge will form in all the three members here, here, as well as here. Now this beam deflects by theta in the clockwise direction. This column also deflects in the clockwise direction because of this horizontal load. So the angle between this beam and this column remains 90 degree here. So there is no hinge generated between this and this member as well as in this. So the hinge will generate only in the third member. Okay. So that's why this is your, now here this plastic movement capacity is 2 MP. So twice MP times of this theta. So this is 2 MP. Okay. Then consider this one. Twice MP times 2 theta. Twice MP times 2 theta. Then come here. MP times, this is my theta and this is my theta for this column. Okay. So theta plus theta. Then we have 1 MP theta here, 1 MP theta here, and 1 MP theta here. So summation of all these is 12 MP theta. So this equate the two, we will get MP is equal to 25 kilonewton. So here it is to note that there is a joint mechanism at joint F here. Joint beam FGH is rotated by theta. Column BF is also rotated by theta, as I told you here. This is rotated by theta. This is also rotated by theta. So net change in the angle is 90 between this and this member. So there is no hinge is formed in beam FGH. FGH, no hinge is formed here. Okay. So only hinge in the third member of the joint mechanism, that is DEF remains. So hinge will form in this here, in this. Okay. So this is the plastic moment capacity of the combined mechanism. So this is all about the various problems of the combined plastic moments of the frames. Okay. So let us, this lecture is completing. Thank you very much.